Okay, I'm going to do my best here to try and explain what brownouts are, what a BEC is inside of an ESC, what a UBEC is, and how they kind of all tie in together. First, we're going to try to get a grasp on what exactly a brownout is. A brownout is anytime the voltage going to the receiver drops below a predetermined value. For spectrum, that predetermined value is right around 3.5 volts DC. How do you know if you suffered a brownout? Your receiver will actually let you know by flashing. It'll flash at a slower pace than it would be if you were binding. If you're binding, the receiver will flash very rapidly. When you suffer a brownout, it'll blink a little bit slowly. So first, it kind of works in sessions, and what I mean by a session is anytime the receiver and the transmitter are connected, consider that a session. How we do that is we're going to properly turn everything on like we would if you were at the field and plugging in your model. You always turn on the transmitter first. Once the transmitter is powered on, I can supply power to the receiver. As you can see, the receiver LED is solid at this time. That's saying that it is properly connected and that a brownout has not yet occurred or has not occurred. So let's go ahead and simulate a brownout. I can do that by simply removing power to the receiver. That just simulated that the receiver dropped below 3.5 volts by removing the power away from it. The session, however, is still continuing because I have not yet turned the transmitter off. So as soon as I plug the receiver back in, you will see the LED flashing. In terms of the transmitter receiver talking to each other, the transmitter believes that a brownout has occurred because the receiver has dropped offline and it can no longer visibly see it. So as soon as I supply power back to the receiver, you will see that it is slowly flashing, indicating that it has experienced a brownout. So how do we properly end a session? If we're at the field, we would disconnect our model and then we would turn our transmitter off. Okay, once the transmitter is completely turned off, when I turn it back on and plug in my receiver again, that is considered a new session. So anytime you're at the field and you want to change battery packs in your model, you want to turn your transmitter off and then turn it back on to successfully start a new session. So I'm going to turn my transmitter back on. And now I'm going to plug in my model, and you will see that the LED is solid. A successful new session has begun. Now there's a couple different combinations on how this can work. If I turn my transmitter off while the receiver is still plugged in, the LED drops offline because it's not communicating with each other. But as soon as the transmitter comes back on, you'll see that the LED is solid. Now why that is because as far as the transmitter is concerned, it's the first time that it is seeing the receiver being visible. So it really doesn't matter to the transmitter on if you power it in, or excuse me, if you turn it on first or second. It only matters as when it's powered up and it can see the receiver. So how would you see a brownout in flight? If everything is set up and when you take off your model and you're doing and you're flying, or if it's a boat, you're driving a boat or whatever, when you come back and you see your receiver flashing, that is indicating that that brownout has occurred and that you need to rethink your setup a little bit differently. That's saying that at some time during that session or during your flight, the receiver powered below 3.5 volts. that is very bad because you temporarily lost signal to your model. Now it happens very quickly, but you really need to honestly rethink your setup. So as you can see, the receiver is getting 5 volts right now. And this is going to lead us to what a ESC BEC does and what a UBEC does. Okay, I'm going to show you a typical scenario in which you would see a brownout. The receiver pack that I'm using is very low right now. As you can see, it just starting to drop off because it's not fully charged at all. So what I'm going to do is show you exactly when that's going to cut off, and you'll see a brownout, and the brownout's going to be indicated on when the red light starts flashing. So I'm going to start moving my servos very rapidly, and you'll watch the voltage drop, which is dropping on its own right now due to the battery being low, and you'll see it start to flash on when we actually experience brownout. And that's how a brownout